Let's learn how does a computer actually work. We're going to start with the CPU, and we'll see what happens from the time that it fetches an instruction until it sends the result back out to be displayed on your screen. We'll talk about what the CPU is, what ROM and RAM are, what the address bus, data bus, and control bus are, and what address decoding is. At the end of this video, I think you'll have a much better understanding of how the basic computer works. Let's get started. The CPU, or Central Processing Unit, is like the brain of the computer. It has millions and millions of transistors inside of it that can be turned on or off, representing either a 0 or a 1. These transistors work together in groups called cores that take the binary code from the software you run and turn it into the actions that you see on your screen. Most modern CPUs have more than one core, and as a result, they're called multi-core processors. The more cores you have, the more instructions the CPU can run at the same time. Now, there are other parts to the computer, like a graphics card that handles certain tasks more efficiently than the CPU. But for now, let's just focus on the CPU. In order for the CPU to run, though, it needs to grab the instructions from somewhere. This is where the ROM comes in. ROM stands for read-only memory, and it's where the basic firmware of the computer is stored. Firmware is essentially software that's burned onto a physical piece of hardware. In the case of a computer, this is the bare minimum code that's required for the computer to function properly. Think things like turning on the monitor or keyboard when you press the power button, or storing the data temporarily while you type on the keyboard. Without the ROM, your computer wouldn't know how to respond to any of the inputs, or how to make sense of the data that it's trying to process. So now that the CPU knows how to respond to simple commands, the next step is to give it some data to work with. That's where the RAM comes in. RAM stands for Random Access Memory, and it's used by the CPU to store data temporarily so that the CPU can access it quickly, unlike the ROM, which is burned onto the hardware. The data in the RAM can be changed. This means that the CPU can use the RAM to store anything it needs, to temporarily, such as the current spreadsheet you're working on, or the web page you're currently viewing. The key here is that the RAM is volatile, meaning that if the power goes out, everything in the RAM will be lost. That's why saving your work to the hard drive is important. If the power goes out while you're in the middle of typing up a paper, you don't want to lose all of that work. Okay, so now that we've talked about the major components, let's dive into how the CPU connects to the rest of the hardware. Let's look at the connections between the CPU, RAM, and ROM. You can see that there are 3 sets of lines connecting these components. These are called buses. A bus is essentially a communication pathway between 2 or more components. And in this case, the 3 buses are the address bus, data bus, and control bus. First, let's look at the address bus. The address bus is a set of wires that carry the address of the data that's being accessed. To understand this, we need to talk about how the CPU accesses the RAM and ROM. As you can see, both the ROM and RAM are divided into multiple locations. Each location has an associated address. So if the CPU wants to access a particular piece of data, it sends out the address of that data on the address bus. For example, if the CPU wants to access the data in the 3rd location of the RAM, it would send out the number 2 on the address bus. Remember that in binary, 1 is represented by 1 and 0 is represented by 0. So if the CPU wanted to access the 3rd location, it could send out the binary equivalent of 3, which is 11. But for simplicity, I'm just going to stick with base 10 numbers. Now, the reason the CPU needs an address bus is so that it can tell the RAM and ROM which location to access. The address bus is separate from the data bus, which carries the actual data. Next, let's look at the data bus. The data bus is a set of wires that carry the actual data being accessed. So if the CPU is trying to read data from the RAM, the data bus is where the data is carried. Finally, let's look at the control bus. The control bus is a set of wires that carry control signals between the CPU, RAM, and ROM. These signals tell the devices on the other end of the buses what action to take. For example, the control bus might send a signal to the ROM, telling it to send out the data that's stored at a particular address. Or it might send a signal to the RAM, telling it to write data to a particular address. To recap, the address bus carries the address of the data that's being accessed. The data bus carries the actual data, and the control bus carries the control signals. These three buses work together to allow the CPU to communicate with the other components of the computer. Now that we've talked about how the buses work, let's put it all together and see how the CPU uses the buses to fetch an instruction from the ROM and then store it in the RAM. First, the CPU sends out the address of the instruction it wants to fetch on the address bus. The ROM then sends the data on the data bus because it knows that the CPU is asking for the data at a particular address. Next, the CPU needs to tell the RAM where to store the instruction. It does this by sending a control signal down the control bus. This tells the RAM to write the data to a particular address. Finally, the CPU reads the instruction from the data bus and stores it in the RAM. Now the CPU can use the instruction to perform some action, such as adding two numbers together. The result of the calculation would then be sent back out through the buses to be displayed on the screen. The entire process of fetching an instruction from the ROM, storing it in the RAM, and then executing it takes only a few clock cycles. A clock cycle is just a single tick of the clock that's inside the CPU. Modern CPUs are so fast that they can execute billions of instructions every second. Another important thing to mention is something called address decoding. Address decoding is the process of taking the address sent out by the CPU and converting it into a signal that can be understood by the other components. For example, the CPU might send out the number 2 on the address bus, but the ROM and RAM need to receive the address in a different format. This is where the address decoder comes in. The address decoder takes the address sent out by the CPU and converts it into a format that the ROM and RAM can understand. This is done by placing a special chip called a decoder between the CPU and the other components. The decoder then converts the address sent out by the CPU into a series of signals that can be understood by the ROM and RAM. Let me give you an analogy. Imagine that you live in a big city and you want to visit a friend. Your friend lives at 123 Main Street, but the GPS in your car can't understand addresses in human language. So you need to convert the address into a format that the GPS can understand. This is where the address decoder comes in. The address decoder is like a translator that converts the address into a format that the GPS can understand. The GPS then uses the converted address to navigate to your friend's house. Similarly, the CPU sends out the address in a format that it understands. But the ROM and RAM need to receive the address in a different format. So the address decoder converts the address into a format that the ROM and RAM can understand, and then they can access the correct location. Now, this was just a very high-level overview of how computers work, but hopefully it gave you a good foundation to build on. There's a lot more to learn, but you can start by checking out this video over here that talks more about how CPUs work, or this other video over here that talks about how memory works. Thanks for watching, and I hope it helped.